Hello friends, this is Professor Prafulla Pawar from Mechanical Department, and in today's video lecture we will see how to construct a parabola by a method called as eccentricity method. So we'll see this method, eccentricity method, which is also known as Directrix focus method. Okay, so we'll see this method and how a parabola is constructed. With the help of this method we will try to understand. So we'll directly take a problem statement, but before that we will see one formula which is about eccentricity. So eccentricity, it is the ratio of distance of point from focus and distance of point from directrix. So since this method is directrix focus method, so one point that we have to locate with respect to focus or with respect to directrix, that we will see, and that with respect to this ratio we will get one term called as eccentricity. Now one more thing we try to see, that for parabola this eccentricity value is equal to 1, which means that the distance of the point from focus and distance of point or that same point from directrix, it is same. So when this ratio is same, we'll get the value as 1. So we'll see a problem statement. The problem statement says that problem, draw a parabola by Directrix focus method if focus is 60 mm from directrix. So this is what we have, the problem statement, in which the distance of focus from directrix is given and that distance is equal to 60 mm. So first of all, when we are drawing this or when we are doing the construction to get the parabola, one thing we have to do is we have to draw a vertical line first, and this vertical line is nothing but directrix line. So we'll name this line as directrix. After that we'll draw one more line, and that line we will draw horizontal. Now this line, it is basically called as the axis line. So there are two lines that we have drawn, one vertical line called as directrix, the horizontal line called as the axis. Now we'll name one point on where we have the intersection of axis and directrix. We'll name that point as A point. Now A point is basically the directrix point. Now with respect to directrix point, we can locate the focus whose distance is given 60 mm. So what we will do is we will mark a point at a distance of 60 mm from this A point, and that point will be our focus point. So I will use a scale here, and at 60 mm I will mark one point, and that point I will name it as F point, which is nothing but focus point. Now after that we have to locate a point. Since eccentricity value is equal to 1 for parabola, which means that the distance of this point from focus and from directrix, it is same. Now we have a directrix point, that is A point, focus point, F point. Now the point will be located in between this A and F, which is nothing but the midpoint of A and F. Now this A and F distance is given 60 mm. So this distance we have 60 mm now. This distance is what we have, 60 mm. This is 60 mm. So if I locate the midpoint of 60 mm, it will be at 30 mm. So I can locate a point at a distance of 30 mm, and I will name this point as V point. So when I see this particular thing, this distance of point from focus will be VF and distance of that point from directrix will be VA. Now when I check it, VF is equal to 30 mm, VA is equal to 30 mm, so 30 by 30 ratio will be equal to 1. That satisfies the condition for eccentricity in case of parabola. So we have this V point, or the point we have located with respect to F or with respect to directrix, that is at the midpoint of 60 mm. Now after that, what we have to do is we have to draw a vertical line. So we'll draw a vertical line from V point. So we'll take a line in upward direction like this. Now the length of this line should be equal to the distance VF, that is 30 mm. So what we will do, we will directly take 30 mm distance on this vertical line, or we can just mark one angle over there. So I will take a compass. I'll keep the compass at V point here. I'll take the distance as distance is equal to VF, like this, and I will draw one arc. So now I have this point I have, where I will name this point as B point now. Okay, so VB is equal to VF, VB is equal to VF, that is the condition. Now next what we have to do is we have to connect A and B point, and we have to just extend that line. So what I will do is I'll connect A point to this B point, and I will just extend this line further like this. Okay, so far what we have done, we have drawn a vertical line called as directrix, horizontal line called as axis. Then this A point, it is the directrix point. With respect to A point, we have located focus point whose distance is given 60 mm. Then we have located the point at the center of this 60 mm so that it will satisfy the condition of eccentricity of parabola, which is equal to 1. Then we have drawn a vertical line from V point, and the length of this line should be equal to VF distance, that is VB is equal to VF. Okay, and then we have connected A point and B point, and we have just extended the line. Now what we have to do is, on the right hand side of this V point, we have to take a number of points. You may take those points at equal distance, or random distances also fine. So what I will do, I will just take random distances from here. So I'll take one point here, I will name this point as point 1, this point as point 2, point 3, point 4 and point 5. So I've taken 5 points. Now what we have to do is we have to draw a vertical line from each point. So whatever points we have drawn here, we'll draw a vertical line from each point. So point number 1 I have taken at a certain distance on the right hand side of A point. Now I will draw a vertical line passing from point number 1 up to this line which we have extended above, and below we'll just extend that line downwards also. So we'll take it at point number 2 also. I'll take the scale here. Vertical line I need to draw up to this AB line which we have extended, and below we'll just extend the line. Similarly from third point here, and below I'll just extend this line. Then I'll shift it to point number 4 here. I'll draw one vertical line up to point number 4, and below also I will just extend it like this. Then at point number 5 I will shift my scale, draw one vertical line up to point number 5, and then below I will just extend the line. like this. So these lines, vertical lines, what we have drawn from each point up to this AB line, and below we have just extended the line in downward direction. Now these points what we have here, this point, this point, this point, this point, and this point, I will name those points as 1 dash, 2 dash, 3 dash, 4 dash, and 5 dash. Okay, now what we have to do is we have to take distance 1 dash in the compass. So I'll bring my compass here. I'll take the distance 1 dash in the compass. This distance I will take it in the compass, 1 dash. Keep my compass on this. Keep the compass on focus point, and I'll take 1 dash compass distance I will take. So this distance I will take, I'll keep the compass on this focus point, and I'll just cut this line, vertical line, which is passing from point number 1. Below, also below I need to make the marking here also. Above and below the axis, I'll just cut the line. Now whatever these points we have, so we'll get this first point intersection here. I will name that point as P1, and below I will name it as P1 dash. Now similarly I will take distance 2 dash in the compass, 2 dash in the compass. Keep the compass on the focus point. Keep the compass here on the focus point, and cut the line which we have drawn from point number 2 above and below the axis. So above the axis also we will cut. This distance will take 2 dash. Shift it on this point F, and we'll just cut this line, and we'll name this point here as P2 dash, and this upward point here as P2. Similarly I will take distance now 3 dash in the compass, 3 dash. Shift the compass on the focus point, and we'll just cut this line passing from point number 3 in the upward direction. Similarly in the downward direction, that is below the axis. And I will name this point here as P3 and this point here as P3 dash. Now the same thing we have to do. We have to take distance 4 dash in the compass. Shift the compass on focus point, and then cut the line which we have drawn from point number 4 above and below the axis. So we'll get this point as P4 dash, and above we'll get point P4. Now the last point is 5 dash distance in the compass. 5 dash distance in the compass. Keep the compass on the focus point, and then cut the line which we have drawn from point number 5 above and below the axis. So this line, and similarly above the axis here. So we'll get this point here as P5 and this point here as P5 dash. So now we have the points P1, P2, P3, P4, P5 above the axis, and P1 dash, P2 dash, P3 dash, P4 dash, P5 dash below the axis. So we just need to connect the points starting from V, then P1, P2, P3, P4, P5, and then below V, P1 dash, P2 dash, P3 dash, P4 dash, P5 dash. So we just connect those points now. So I'll connect point V, P1, P2, P3, P4, P5, and similarly I will connect V, P1 dash, P2 dash, P3 dash, P4 dash, and P5 dash. So this curve, what we have got through connection of these points, that curve is nothing but parabola. Okay, so this is the procedure, or this is the method, that is Directrix focus method, or it is also called as eccentricity method, to do the construction in order to get the parabola. I hope you have understood. Thank you.